Hello everyone. Here we'll continue again properties of soil. In this, I'll discuss about water content, or it is also known as moisture content. The reference is IS 2720 part 29 of 1975. We'll go into the details. Moisture content, there are number of methods. Here we'll be discussing about oven drying method. Now, first of all, what is moisture content? Moisture content is the ratio of mass of water to the mass of soil solids in the soil. So it is mass of water to soil solids only. It is not mass of soil in the denominator. Right? That is what is the definition of moisture content. Now, what is oven drying method? This is an accurate method of determining water content of soil in the laboratory. And most of the time, 90%, 95% of the time, in soil mechanics laboratory, we use oven drying method only. Okay, the procedure is as follows. Take a container, note the number engraved on it. Okay, the containers will be possessing some number on the container. Generally it will be engraved on that because these will be steel or aluminium cups, and then the number is imprinted or engraved on that will be used. Okay, so here I have a photograph of containers, water content containers. Here there are empty ones. Here there are already some soil has been put into that. You can observe, and you can see here there are some numbers that are written on top of each of these containers, so that you will be able to recognize in which container what kind of soil that you have put, or masses of which containers you have recorded. To know that, you should note down the number on top of it. So these are the kind of cups or containers which are used for water content determination, and you have a balance which measures an accuracy of 0.01 grams. Okay. Okay, take a container, note the number engraved on it. So you have to note down number here, container number. Suppose if we are working with sample number 1, so you have to note down the number. Next, find the mass of empty container and the lid equal to m1 grams. So mass of empty container plus lid will be m1. It is represented as m1, and it has to be noted in grams, that is m1. Now put a representative soil sample in a steel container carrying a lid. Of course, the lid is there. Find the mass of the container along with wet soil, and on top of it the lid, right? That is m2. So mass of the container plus wet soil gives you a mass of m2 grams. Okay, then keep this into the oven. Keep the container with lid open. So make a note of this. Lid is used, but when you are keeping it inside the oven, so with lid open you have to, right? Only when transportation, there should not be any change or disturbance to the wet soil. That's why lid is used. Otherwise, when you keep it inside the oven, so you have to keep with the lid open in a thermostatically controlled oven for 24 hours. Note down how much time that we have to keep it is 24 hours, and at around the temperature adjustment, if it is there, it has to be adjusted to 100 plus or minus 5 degrees centigrade. That is maximum of 105 degrees centigrade that we have to keep, so that water that is present inside the soil gets evaporated and completely evaporated without any traces. That's why you have to heat it for 24 hours as a standard. Okay, now after 24 hours, when you come back, you have to, after cooling the container, means you have to take out the container, you have to allow it to cool, find the mass of the container and the lid along with dry soil. Means after putting it inside the oven, it gets completely dried, but you have to keep it, cool it outside, and then afterwards you have to take the mass, and then the container with the dry soil along with the top or lid measures m3 grams, that is m3. Now further calculation is mass of the water that is present inside the soil will be simply m2 minus m3, because container is there, container on top, lid is there, everything is there, the soil particles are there, only that is missing between these two is water has got evaporated. So mass of the water present in the soil, or mass of the water that was present in the soil, would be m2 minus m3, that is mw so many grams. Now mass of dry soil, that will be m3 minus m1. So here the common thing is only the container, that gets subtracted, you will be left with only dry soil sample. So m3 minus m1 gives you mass of solids or mass of dry soil. So though it is mass of dry soil, we can always refer to it as mass of soil solids, MD. Now moisture content in percentage is given by the MW divided by MD into 100. That's how to calculate water content. Now for better reliance, what you have to do is for the same soil sample, you take around 3 samples in 3 different containers, work out the water content, and actually all of them should give almost same value, so that you can take the average of the 3 and present it as the final result of water content. Right? Out of the 3 results, if 2 are consistent and then 1 is going wayward, then you can discard that particular value and then take only the average of the 2 which are more consistent and present it as the result. And by chance, if all the 3 are quite differently showing the values, then you cannot rely upon the result. You cannot take the average and present it as the average water content. This particular point has to be quite noted when you are conducting an experiment. Okay, welcome back again. Here we'll be discussing about moisture content by calcium carbide method. How it is different from oven drying method is, this is a rapid moisture meter, in the sense here without waiting for 24 hours we can find out the moisture content. That is the advantage of calcium carbide method. Slightly it is not accurate, you can say, but one can get good or fair amount of moisture content idea by this method. So it is a quick method of determination of water content. Now what it consists of, I'll show you a photograph of that. So here there is a whole box containing whole equipment. Okay, here there is a container. This is the one in which the soil and calcium carbide will be mixed with a closed top. We'll talk in detail about this. Here there is an interesting balance which will help to take exactly 6 grams of soil. Here there is a chemical calcium carbide. Here there is a spoon which will help you how much calcium carbide has to be taken. 1 scoop of calcium carbide has to be taken from this. This is a calibrated spoon. This is to clean the container after the test. Okay, so it consists of an airtight container with a diaphragm and a calibrated meter. So this will be having an airtight container, and this there will be a diaphragm which will be sensed by a dial gauge here, which will be directly reading apparent water content. Apparent water content is nothing but water content with respect to wet soil. Right, we'll talk in detail about that afterwards. Now, next point is about 6 grams of soil is mixed with fresh calcium carbide. So how to take exactly 6 grams? This balance helps. There is one more picture here. The same thing. If you look from this end, here there is a calibrated one balance. So it measures exactly 6 grams. Means when you put it inside this 6 grams, this perfectly gets lifted. So that's how you can measure exactly 6 grams of soil. So that much of soil has to be taken into this container. The mixture is vigorously shaken. Water in the soil reacts with calcium carbide to release acetylene gas. Means when it is mixed thoroughly, of course there will be some steel balls inside, and then you close it very tightly and then shake it vigorously. What happens is there will be acetylene gas which will be released. The amount of gas produced depends upon available water. Means if there is a less of water, there will be less of gas produced. If there is more of water, more of gas is produced. Accordingly, the pressure will be more or less on the diaphragm and the reading also. This gas creates a pressure on sensitive diaphragm, and the water content is directly recorded on the calibrated meter. The method is not very accurate, but it is extremely rapid. Now inside this container, you can just see here the green thing is nothing but sample, soil sample, and there are steel balls of various sizes, and the chemical is mixed, calcium carbide is mixed. Then very tightly this will be closed. You can see the assembly here, and then it will be shaken. Now whatever gas is produced, that will be actuating a diaphragm. In turn it gives you the reading. So that is what is calcium carbide method. Now here in this method, the reading on the meter gives the ratio of mass of water to mass of wet soil. You can just see mass of water to mass of wet soil. It is actually the water content definition is mass of water to mass of soil solids, that is dry soil. But this reading gives the ratio of mass of water to mass of wet soil, and let it be represented by W dashed. So what is W dashed? It is weight of water divided by wet soil weight, which is nothing but weight of water plus weight of dry soil or soil solids. Now we can write it as inverse of this, inverse of this. So this divided by WW will be equal to 1 by W dashed. Now this will be reduced to 1. This by this will be nothing but weight of solids divided by weight of water is nothing but 1 by W, because water content is weight of water divided by weight of solids. That's how. Now from this I can work out for this W. From this we can write W is equal to W dashed divided by 1 minus W dashed, where W is nothing but weight of water divided by weight of solids. Though we have a reading from the calcium carbide method, this W dashed, we can reduce it to whatever required water content by this expression. That is what it means. So this is the second method, which is a quick method, or it is called a rapid method, which is known as calcium carbide method. Okay, next in the line is under index properties, there is what is known as relative density or density index, ID. There are so many other indices also, but this is the one which will be defined as density index. We'll see in detail about this also. Okay, what is density index? Expression wise, it is ID equal to E max minus E natural divided by E max minus E minimum. Now what is E? E is a Voids ratio. Voids ratio, maximum Voids ratio minus natural Voids ratio divided by maximum Voids ratio minus minimum Voids ratio. This is the expression for density index. Okay, a reference is IS 2720 part 4, part 14. Now there are two values, E max and E minimum have to be found in the laboratory. E natural is calculated indirectly by knowing dry density of the field. Right, knowing the dry density on the field, we can calculate E natural. But E max and E minimum have to be worked out or determined in the laboratory. Now how it is determined? To find E max, what we'll have to do? Fill 1000 ml graduated glass cylinder up to 500 ml with distilled water. We have to fill the water up to half of 1000 ml graduated glass cylinder. Now place a large funnel on top of such that its bottom tip is in the water. Slowly place dry soil into cylinder through the funnel such that particles settle uniformly and independently. So when you place the soil enters into the water and gradually falls at the bottom. Now measure the mass and volume of the soil to find dry density and hence E max. Means when it settles down, you will be knowing at the graduated level how much is the volume of the soil, and also when you pour it down, you will be knowing how much is the soil that you have let fall inside the glass. So by knowing mass of the soil divided by volume of the soil, I'll be able to calculate dry density. Now from dry density I can calculate E max, because you know that gamma D is equal to G gamma W divided by 1 plus E. Let me try to write that. Gamma D is given by, you know this relation anyway, I'll write it once again. It will be capital G gamma W unit weight of water divided by simply 1 plus E. This is the relation that we are going to use in this. This is weight of soil solids divided by volume gives you gamma D, and we know specific gravity, we will be knowing this also. So only unknown in this equation is E. So this is loosely filled, because of that it will be E max. Now to find E minimum, place the soil in compaction mold with collar in wet state. Using needle vibrator, compact it and add more of soil to fill beyond the collar. Okay, you compact it in that way. Now remove the collar and level off the soil. Find the volume and dry mass and hence dry density. Now using this much of information, we can calculate once again E, and this E will be E minimum, which can be determined. Now once you know E minimum and E maximum, the earlier E natural is already known, so because of that ID can be calculated. Now when you get some value of ID, what is the kind of inference that we can draw? That is what is discussed here. Now range of values of ID. Now observe that Emax and Eminimum are determined in the laboratory. That is what is over here in the laboratory as mentioned alongside. Now if the soil is very compact in its natural state, then the natural White's ratio will be A minimum. White's ratio minimum in the sense it is compact enough, right? Natural White's ratio will be equal to E minimum, hence ID will be equal to 1. How? When E natural is equal to E minimum, E max minus E minimum divided by E max minus E, this ratio becomes 1. That's how this becomes 1. When E natural is equal to E minimum or soil is quite compact. Now if the soil is very loose in its natural state, the natural White's ratio will be E max. Natural White's ratio will be E max. So E max minus E max, it reduces to 0. Hence ID will be equal to 0. What is the conclusion? The value of ID nearer to 1 indicates denser state of soil. The value of ID nearer to 0 indicates that it is a looser state. Spelling has gone here anyway, right? Value of ID nearer to 0 indicates looser state. In between, when you have, obviously you can decide. For example, if ID is 0.8, obviously it is denser, not to the densest state. And then if ID is 0. Let us say 4, yeah, it is in loose state. Like this we can infer from the value of density index what is the denseness of the soil. That's why it is called density index. It is also referred to as a relative density. Okay, we'll stop here. Thank you.